before we go over all these different rates, we need to introduce a couple of conventions, and here they are. The first thing is I need a way to specify molarity in a kind of more concise way. And that is done by putting square parentheses or square brackets around something. So if I need the molarity of NO3-, I don't want to spell it out anymore, or I don't want to give it one symbol, because I need the molarity of all kind of reactants and all kind of products. And so I need to be able to talk about all of these things in one equation. And so I need a symbol for molarity of a chemical compound or of some chemical I have in solution. And square brackets around something means molarity of. It isn't a mathematical symbol, right? If you want to use parentheses in mathematics, that's fine, but square brackets mean molarity of. So NO3- means molarity of NO3-. If I want the molarity of sodium plus, I write square bracket, sodium plus square bracket. The next thing is I might put something like A or B or C into the molarity, into the parentheses, and that's a placeholder. That A is of course not in the periodic table, B doesn't mean boron, and C doesn't mean carbon. It just means chemical A, chemical B, chemical C. It's very much like a placeholder X, Y, Z in math. In math you compute it with numbers, and that will be specific chemicals like NO3- or sodium plus or Cl- or NH4+. But at some point you kind of went up one level and you did algebra and you tried to do mathematical expressions with letters, with variables like X or Y or Z, because you need to do something that is more general. And I want to write out my kinetics laws in a more general way, and so I want to write them out chemical independent. And so I need some placeholder for any chemical, A, or for, if I have two chemicals, two reactants, A plus B, then I need the concentration or the molarity of A and the molarity of B. Now, these molarities change over time, so I need some way to express this at a specific time. And I put this time here as a subscript to the bracket. So this is the molarity of A at time t. If I write A 30 seconds, I mean the molarity A after 30 seconds. 30 seconds after the reaction has been started. And if I write 0, I don't need to write a unit, right? Whether it's 0 seconds, 0 minutes, 0 hours, 0 days, that doesn't make a difference. If it's 0, it's 0. That's the molarity of A at time 0. That's the so-called initial concentration. Once this is actually a number like 30, or I have to say, is it 30 seconds or if it's 30 minutes? That makes a big difference. But if it's 0, I don't have to provide a unit here. And then there's rates. And this is an overview over the 5 rates that we are going to consider in this chapter. There's one more in this chapter, but I will kind of leave it out. And there's average versus instantaneous rates. And the average rate is what you think it is. And the instantaneous rate means also what you think it is. So your instantaneous rate for your car is, hey, it's the rate, it's the speed of your speedometer. The average rate is if I go from place A to place B and I take a total time, the total distance divided by the total time. That's the average rate, right? How fast was I going on average, regardless of how many stop signs there were and how fast I was here and how fast I was on that leg of my journey. Instantaneous means how fast am I at any point in time. So those two are different, right? This is much more important. Instantaneous is what I'm usually interested in, right? If you are going somewhere with your car, you want to know what your speedometer reads. You don't want to know in the end when you get there what was my average speed. You might calculate that, right? Google gives you probably your average speed when you go and you kind of click 2 points. Google can give you your average speed. But gee, it's not the most relevant information. The consumption versus the production rate, that applies usually to a reactant and to a product. So reactants are consumed, so they come with consumption rates. Products are produced, they come with production rates. But they are related to each other, right? Because they are related by the chemical reaction. Once you know a consumption rate, you can compute all the other consumption rates, and you can compute all the production rates. So once you know one, you can compute all the other ones. And that's because, hey, this is usually you measure one. You measure in an experiment the consumption rate of one of your chemicals or the production rate of one of your chemicals, and then you can compute all the other ones you actually want to know. And the reaction rate is one rate that sort of normalizes all the consumption and production rates, and we shall see how that is achieved. And so that makes this information, consumption and production rates, independent of which chemical you observe. So whenever, it doesn't matter which one you observe, and this is what is usually reported when you do a kinetics experiment. One person might observe the consumption of one of the reactants, another person might observe the production of another chemical, of a totally different chemical, but they will report the same reaction rate, and that's what the reaction rate is for. So those three are related by one equation, and once you know one of those three, you can compute the other ones. So when somebody talks about rate and leaves out all the adjectives, what is implied is instantaneous reaction rate. Reaction because that's what is reported, and instantaneous because it's much more important than average. If you don't mean that, if you mean explicitly a consumption or production rate, you have to use the adjective. If you don't mean instantaneous, if you mean average, you have to use the adjective. But if those adjectives are not used, instantaneous is meant and reaction is meant. It's like, hey, a car comes with different speeds, right? There's a speed how fast gas is used. There's a speed how fast CO2 is produced. There's a speed how fast you're actually going. And if you don't use any adjectives, any quantifiers, then hey, what is implied is the speed how fast the car is going. But if you want to apply, if you want the gas mileage, then you have to say, hey, I mean the gas mileage, right? And that's the instantaneous reaction rate. That's a natural thing to talk about if you just say rate.